So our learning goal does state today that I can find rate of change, and we're going to refer back to what were rates, we learned those already, and slope. I can relate, and then I can relate a constant rate of change to a slope. Okay, so let's go back to what is a rate. Okay, rate is a comparison of two numbers with different units. Does that sound familiar? A rate is a comparison of two numbers with different units. So can you give me any examples of rates we worked with back in another chapter? Anybody get paid by the hour? At a job? Okay. So dollars per hour is a rate. That's in fact it's miles per hour. In fact, those are unit rates. When we do it per one, we're talking about unit rates. So rate of change, when we're working with rates of change, it's really the same thing. We're comparing two numbers that have different units of measure. And so we're going to call, just like a rate is a ratio, we're going to call rate of change a ratio. But how are we going to find rate of change? Well, the comparison in this one is the amount of change in the dependent variable. What is that typically our dependent variable again? Y, the Y value. So a change in the Y values to the amount of change, or in other words, downstairs in our ratio will be the change in an independent variable. And our independent variable is most typically what? X. So we're going to be talking about, when we talk about rate of change, we're going to set up a ratio. But in that ratio is going to be some subtraction going on because we need to find the amount of change that is going on. We need the dependent change upstairs, we need the independent change downstairs, and it's over a specified interval. Over a specified interval. So we're going to do the check it out problem at the bottom of page 244. So let's go take a look at it. They've done an example that you can study on your own also up above. And we're going to do the check it out number 1 at the bottom of the page. The table shows the balance of a bank account on different days of the month. Find the rate of change for each time interval, and then during which time did the balance decrease at the greatest rate. So they're already asking us that apparently the balance is going to be decreasing sometimes, and they want to know which one, over which interval is it the greatest, okay? So first thing we always have to decide in these is we aren't going to go just with the order that they're given in the table. We're going to do just like we did when we were setting up rates. We're going to set them up with a comparison that makes sense. So in this one we have a bank balance, which would be in dollars, and we have the day number. So which day is it? Which number day is it? So does it make more sense to say days per dollar? So when we divide it out, would it make more sense to say how many days per $1? Or would it make more sense to say how many dollars per 1 day? Yeah, it makes more sense to say dollars per day. So let's put that over here. Dollars per day makes more sense. So we have to decide that first. Once we decide that, that helps us say, well, okay, well then our dependent variable is going to be the balance. And of course it's in dollars, that's why we said dollars up there. So the bank balance, how much is the balance in the bank? And the independent variable is going to be downstairs. Remember, the change of the independent is downstairs, so that's going to be the day. Once we know that, then we can set up our problems with that and get answers that will make sense. Okay? So our intervals they're determined by what they give us in the table. We have information for day 1, and then our next bit of information is for day 6. So we're going to start with what's the change in the bank balance. So we're going to show our subtraction that we're going to do. Let's start at $550, day 1. $550, take away how much money was in the bank on day 6?
$285.
285. There's the change in the dollar amount over, we're going to stay in the same order, day 1 subtract day 6. So first of all, what's 550? Take away 285. What do we get? 265?
Yeah.
Okay. Positive or negative? Positive, okay. 1 take away 6. Negative 5. And now you'll just divide that out. This would be a great time to have a calculator again. If you want to do it in your head, that's cool too. 265 divided by 5. Positive divided by a negative. AJ?
Negative 53.
Negative 53. Okay. And that's negative 53 what? Per what?
Dollars per day.
Dollars per day. So we just found out how many dollars per day, on average, that bank balance decreased over that time interval. Okay, let's go to the next time interval, day 6. Now, so we started day 6, the point we just left off at, and go to the next time that they measured it, and it was on day 16. So we're going to do the bank balance on day 6, which was $285. How much was it on day 16? 210. Okay. And we're going from day 6 to day 16. So 6 take away 16. Order matters. If we're going to go with day 6's bank balance upstairs first, day 6 is first downstairs. Well, that's 75, isn't it? Over negative 10. What does that divide out to? Negative 7.5, and since this is money, we'll put a 0 there. Negative $7.50 per day. So again, this is an average. Over that time span, the bank balance went down an average of $7.50 every day. Questions so far? Okay, day 16, the next time they gave the bank balance was at day 22. So now we're going to do the bank balance on day 16 to start with. Take away the bank balance on day 22. How much was it on day 22? 210. Okay. And we're going to do day 16, take away day 22. And what do we end up with?
0.
0 divided by negative 6. So what is that? 0. $0 per day. Or in other words, on the average, there was no change over that time interval. Doesn't mean that there wasn't. It just means that on the average, it averages out to the bank balance staying the same. Okay, and then day 22 to day 30. Go ahead and finish that one up. And it's a nice decimal, so let it come out, write the whole thing. Even though this is money, the bank does operate until the very end. Then they round in the end, but they don't round in the middle. So what does this come out to? 4.375. And is it negative or positive? Negative 4.375. Or in other words, somebody tell me what that's telling us. What's going on there? It's decreasing $4.37.5 per day over that time interval. The bank balance on average is decreasing at a rate of $4.37. The $4.37.5 per day over that time interval. Okay, so what was the greatest decrease from? Which interval?
1 to 6.
From day 1 to 6. From day 1 to 6, the bank balance decreased at the greatest rate. It was a negative $53 per day. So when we look at the absolute value of each of those, that's the one number furthest away from zero. And as I've been saying all along here, each of these rates of change represents an average change. So I want you to put that in here, an average change. We're just finding if we knew every single day what the bank balance was, and we averaged all of those together over that time interval, we would come up with what we just did. So each of these rates of change represents an average change each day during that interval. The actual change each day may have been different. Doesn't mean that every single day it exactly changed by that much. Okay, we're going to go graph that. So go to that graph handout, please. And we're going to see what this looks like on a graph. What should we find is going on a graph? Anybody have any idea? Okay, so you're going to want those ordered pairs beside you, so you can look in the book, or you can kind of look if your notes help you too. So looks like I've already labeled the axes for us. How nice of me. Okay, did I do it right? Is our dependent variable supposed to be the bank balance? The y values? Did I do that right? Okay. How about the x values? Are they supposed to be the days?
Yes.
Okay. And what scale am I going by on the x-axis?
2.
By 2s. And the y-axis? No. By 50. Okay. So we're gonna go and we're gonna plot each of those points, ordered pair 1, 550. So we're gonna go to 1, which is halfway between 0 and the 2, and we're gonna go up to 550, and we're gonna put a point there. Okay, halfway between 0 and 2 on the x-axis, and up to 550. The next time they measured it was on day 6, and it was $285. So we're going to go to 6, and we're going to go, what would be 285? Well, just right below the 300, which is not labeled on there, but we know that that one is the 300, so it's kind of right in there. Okay, now I want you to take your ruler as a straight edge and connect those 2 points. That is this is going to represent the rate of change over the first time interval. So you're going to connect those 2 points with a line segment. And then what we're going to do is we're going to show that rate of change. We're going to write it right on the graph. Here's what's happening. It is going down $53 per day. So over that time interval, we are showing the rate of change. Okay, let's plot the next point, which is 16 to 10. So we'll go to 16 and up to 200 and just barely above 200 and plot a point. Whoops, my location. And now you'll use your straight edge and connect from day 6 to day 16. You want better than that? And label the rate of change for that interval. How much was it for this interval? Okay, tell me what we should expect for our next line segment.
Straight line.
Should be what kind of a straight line? These are all straight.
Straight.
Horizontal. It should be a horizontal line change. Line segment. Why?
Because it doesn't change.
There's no change. Remember how when we were reading graphs before, we said when no change represents a horizontal line represents that. So we're going to go to 22 and 210 and put a point and connect those two with a line segment. And label our rate of change. I'm going to go down below because Getting kind of busy above there. $0 per day. And we should have one last point to graph, 30,175. And we would draw our line segment and label that one's rate. $4.37.5 per day. So when you have to graph these rates of change, this is what you'll do. Not only will you plot the points given to you that helped you get the rates of change, but then you will connect the points to show the line segments that represent each rate of change and label those. How does the graph, other than the fact that we wrote the rates of change right on it, how does the graph show that day 1 to day 6 has the greatest rate of decrease? Austin?
It drops like down.
It's, yeah. What, anybody know what word we could use for that? It's the steepest, yeah, it's the steepest of all of those. So the steeper it is, the greater the rate of change, okay? So that's the only rate of change problem we're gonna do. So does anybody have any questions on this? I typically find where students mess up these the most is they do not make a good decision about what should be the dependent variable upstairs and what should be the independent downstairs. So before you go through all the work that is involved with the rate of change problem, make a good choice to start with. Would this look different if we would have flipped it around and done days per $1? Absolutely it would have. It wouldn't be the same thing. Okay, so no questions? Okay, let's go to the back side of the notes handout. And in your book, we're going to go to page, let's go to the middle of page 245. So today you're going to also work with slope, and rates of change are really slopes. They're slopes for that particular specified interval. But when we have a constant rate of change, when slope is the constant rate of change for the whole works, everything on the graph has the same rate of change, no matter what 2 points you go between. When that is a constant rate of change and it's a non-vertical line, we don't talk about vertical lines having slope, we can find it by using any 2 points on the line. So if we have a constant rate of change, you can pick any 2 points you want, and that'll help you find the change that is the rate of change that is going on in the dependent variable over the independent variable. So slope is actually the same as rate of changes. Change in dependent variable over change in independent variable. Change in y over change in x. You've already been exposed to this. What else is it commonly referred to? Rise over run. How much is it rising? How much is it running? Rising is in what direction? Vertical, so we're talking up or down, positive or negative, up or down. And running is horizontal, left to right, negative to positive, positive, negative, whichever way it is running, okay? Now, when you find it from a graph, you basically can do what? What's one thing you could do on a graph to help you find the slope of a line?
Find 2 points.
Find 2 points, locate 2 points, and then what would you do?
You have to count out.
So count up or down, how many units do you have to go up or how many units do you have to go down to be aligned horizontally with the other point, and then move left or right to land on the point. That would be your run, wouldn't it? Okay, now, what do you have to be really careful about when you're counting on a graph? What do you suppose might trip you up on a graph? Shay? How it's numbered, how it is scaled. you need to pay attention to what the scale is on the graph. So let's look at example 3 there at the bottom of the line. Example 3, not check it out problem number 3, but on the bottom of page 245. Those, both the x-axis and the y-axis, what are their scales? What are they counting by? 0.5 by halves, aren't they? So when you go from they started at the bottom point that they have marked, order pair 1, 1, they started there and they counted up. They actually went up 4 grid lines, but that doesn't make the rise 4, it makes the rise 2, because 4 times 1/2 is 2. And the run is not 2, you gotta go over 2 grid lines, but the run is what? 1, okay. So when we're using the graph, we have to make sure that we get to pick any 2 points to do it, but we have to make sure that we are paying attention to what are the axes numbered by, what are the scales on the axes when you're determining that. And then we simplify. So we did have a rise of 2 and a run of 1, and that simplifies to 2. We say the slope of that line is 2. But what happens if somebody else uses those same 2 points on the line, but they start at the top point and they go down to the bottom one? What happens?
It's gonna rise negative.
Yeah, the rise is negative because you're going down, and the run is negative because you're having to go to the left. So negative divided by a negative is a positive. We still end up with a positive 2 though for the slope, don't we? Okay, so let's talk about the different types of slopes we can have. Slope can be positive. That's one of the choices. What's going on with the line when we went from left to right? Is it rising or falling as we go from left to right? Positive slope. It's rising. It rises from left to right. So if you have a line on a graph rising from left to right, you're immediately, and I want you to start this right away, you should say to yourself, that better have a positive slope. It has a positive slope, which means the y values increase from left to right. When we're moving from left to right, the x values are automatically increasing, aren't they? When we move from left to right, the x values are automatically increasing. So what's going to determine whether the slope is positive or not? Are those y values also increasing at the same time? Okay? So if we have negative slope, what's happening as we go on the graph from left to right? It falls from left to right. That's the words I use anyway. It falls from left to right. What's making it fall? As we move from left to right, what's happening to the y values? They're decreasing. So the y values decrease from left to right. Again, when we see a line that is from left to right as we read across the graph, it is falling, we better say to ourselves, oh, there's a negative slope. Well, we just discovered on the front when we were doing rate of change that there is such a thing as a 0 rate of change. And remember, rate of change is related to slope. So 0 slope is what kind of a line? What kind of a line do we have? What's its behavior? Horizontal. There is no falling or rising from left to right. It is horizontal. There is no change. So y values have no change from left to right. No change from left to right. Only the x values are changing. The y values are not. So when we have a horizontal line, we have a 0 slope. Well, undefined is what kind of a line? Vertical. Does anybody know why a vertical line has an undefined slope? What would that be? Which way is it not going anywhere? The horizontal. It's not moving, it's not running any, is it? It's only rising. So if it's only rising and it's not running, what does that mean is upstairs and what's downstairs?
Positive.
There could be a positive or a negative number upstairs. What's going to be happening downstairs? If there's no change, there's a 0. And what's true when we have 0? That's just going to have to go. So probably for my parents, but it's my phone going. So what's going on? What happens when you have 0 in a denominator? Remember that x is the change in
Zero.
x. No, you can't divide by 0. Try it on your calculator. What happens when you try to divide by 0? You get an error message. You get an undefined for x message. You get some sort of a message that says, you know what, folks, you can't do this. Okay? So when we talk about a vertical line, we cannot talk about it having slope. We say it is undefined. There is no change left or right, which leaves us with a 0 in the denominator, and that's an issue. We cannot divide by 0. We cannot divide by 0. So there's 4 different types of slope, and we better be able to look at a graph and say, I already know what type of slope I'm going to have. Positive, negative, 0, or undefined. Okay, slope is a measure of the lines. Anybody have any idea what I might be looking for here? Slope is a measure of the lines. Steepness, rate of change is, you could say that. How steep is it? Remember we talked about that negative $53 per day had the steepest line segment? So when we talk about slope, it's really measuring how steep is that line. How fast is the y value changing compared to the x value? And so here's how we determine which is going to be the line with the steepest slope, the greatest slope, without having to graph it. We're going to look at the absolute value of the slope. What's absolute value again? Absolute value of slope. What's absolute value? Distance from 0. It's its distance from 0. So we're looking for which one has a greater distance from 0. Which one's further away from 0? So as the absolute value of the slope increases, the line becomes steeper. So the greater the absolute value of slope, the greater the steepness. So which line would be steeper? A line with a slope of -3 or a line with a slope of 2?
-3.
-3, why?
It's farther away from 0.
It's farther away from 0. So let's put this. We would say absolute value of -3 equals +3. Absolute value of 2 equals +2. 3 is greater than 2. So slope of -3 would be steeper. Tell me something else. Can you tell me anything else about those two lines? We already know that the one with the slope of -3 would be steeper than the other one with a slope of +2. It would be, so
This would be a negative.
if it has a negative slope, it would be falling from left to right. We don't talk about a negative line. There's such a thing as a negative line. We talk about a falling line, though, falling from left to right. So the one with the slope of -3 should be falling from left to right. Tell me something about the one with the slope of 2. It should be rising from left to right. Let's go to that graphs handout that I gave you again. Let's just graph a line with each of those slopes. No, we don't have any information other than their slopes. So we can still make a random line with a slope of -3 and a random line with a slope of +2. So let's just stick a y-intercept on. This is going to be our one with -3. Anybody know what we have to do to create a line? We just need a starting point. What do we have to do to create a line with a slope of -3? What does that -3 slope tell us again?
Each interval is going down.
Okay, it's going down by 3. In other words, the y value is decreasing as the x value is increasing. So if we go down 3, then we need to do what? Go right 1. And if we just keep doing that, down 3 over 1, down 3 over 1, down 3 over 1, until we have a fair number of points, then we can draw ourselves a line that would have a slope of -3. So take your straight edge and do a better job than I am. Go all the way through the graph like I've talked about when we're graphing. So there they lie with a slope of -3. So we'll label these in a little bit after we get the other one graphed and we'll see which one, where we are going to write it. Okay, now let's do one that has a slope of 2. Again, let's just be random. I don't know, stick one right there, point right there. What does the slope of +2 tell us? Go up 2 and over 1 to the right. Up 2 over 1, up 2 over 1, up 2 over 1. Get a few points. The more points you can make, the better your line will be. Draw your line through the points, all the way through the graph, showing it goes on forever at both ends. And which one looks steeper? The negative one? They're pretty close though, aren't they?
Yeah.
Yeah, it's a little hard to tell, but this is our one that has a slope of -3. Let's put that on our graph. Slope of -3. And this one has a slope of +2. But hopefully you understand that if you had to take 3 steps, let's just take that -3 and think about it as being positive. If you had to take 3 steps up and only 1 step over, another 3 steps up and 1 step over, so you're climbing a hill, versus 2 steps up and 1 over, which one's going to be the more tiring hill? The 3 up and the 1 over, isn't it? It's going to be steeper. Okay, this just happens to be a -3, so it's falling instead. You're going down the hill, I guess, instead of up the hill. Okay, anybody have any questions at the moment? Okay, so those other 2 graphs are at the bottom there. Those go with the 2 on the homework that you're supposed to graph. Hopefully I've written the homework correctly this time, so write that down and let's get you started.